Hello, everyone. Welcome to our session. My name is Piotr Wendykier, and together with my colleague Sean Sheren, we will talk today about file formats for data scientists. So we will start from describing the columnar data structure and how that may look like in the future version of Wolfram Language. Then I will describe the Apache Arrow library, which will serve as one of the backends for that columnar data structure. And finally, in the rest of this talk, I will present three formats: CSV, Parquet, and Arrow columnar format, and compare the performance of Wolfram Language import-export with the corresponding Python libraries. So let's start from the columnar data structure. In the bracket I have here, this is work in progress. It will not be available in soon to be released version 14.0. It is currently scheduled for the next release, but this is work in progress, so we may delay it for some reason. Hopefully not. All right, so what the columnar data structure is. Other names for that structure is data frame, table, or structured data. So from this illustration, it's right. So you might be familiar basically with the, the spreadsheet table. So here we have that each column, it's typically represents the variable, and in each row we have a data point. There could be cells with the missing data. What's important that each column is usually of the same type. There is a homogeneous type in a column. It could be a number, it could be a string, date, or category, etc. However, overall, the table is usually heterogeneous. That is, each column is of a different type. So this is quickly what do we mean by the columnar data structure. What I'm showing here is coming from the our internal prototype build. So again, this is not available in 14.0 beta, and it will not be available in the released 14.0. Tentatively, we call that columnar data structure, we call it tabular. Again, subject to change. The way it works right now, this is the constructor. We take the basically this is the representation of three columns of data: sex, size, and length. We construct it, and there is at this point not really a nice output form, but this will definitely change. This is how it looks like in a table view. Right, so that's the table with three columns. We can extract the schema, underlying schema for that columnar data structure. So the first column is of type string. The second column is real 64, so is the third one. Right, so we basically, in a sense, derive the types based on the entries for each column. Quickly, how we can extract the data, from for each column. So first of all, you can call the data vector table property on that tabular object and get something that we call data vector table. So this is basically the data structure that represents the whole table with 3 columns. Once we have that data table, we can ask for the vector list, and this is basically now 3 vectors that represent each column. And when I call normal, I basically get exactly the values that I entered in the constructor above here. Okay, that's basically everything that I want to show for this tabular project. There are actually many people involved, so hopefully it will be a very nice addition to the next version of the Wolfram language. In the rest of this talk, I will focus on the import and export formats that will be basically returning tabular object as a import will be returning tabular as a default element, and export can basically take tabular object and export it to the formats that data scientists work with. But before that, let me tell a little bit about the already mentioned Arrow library. Arrow library is an open source project developed by Apache Foundation, and the way they want us to think about this is the cross-language development platform for in-memory analytics. That's basically the description taken from the website of the Arrow library. So Arrow provides the building blocks for analytics operation, and we're talking about large data sets, so we can really care about the performance when we talk about multi-gigabyte files. And even though in this talk I will not be discussing any analytic operations, we definitely are very interested in using whatever is provided by Arrow library and using it in our tabular object. But hopefully at the next Wolfram Technology Conference, you will see much more about this and also see comparisons and benchmarks that shows the performance of analytic operations on large data sets. Here, I'm going to focus on the file formats. So Apache Arrow library supports a number of file formats. In this talk, I will discuss 3 of them: Parquet, CSV, and Arrow's IPC. I also mentioned ORC here. We do experiment. We have some implementation of that format. There are some issues with it on Windows platforms, so I'm not going to discuss it more. Hopefully, all of this will be fixed, and we also have this format in the first release of tabular project. Arrow is used by many other projects as a backend analytic engine. The list of the projects can be found at the website. And here I'm providing the list, the full list of available languages that you can, once you develop in any of this language, you can easily integrate Arrow into your software. All right, so how I benchmarked Arrow library in Python and in Wolfram language. I used one quite a large file in the benchmark. So the file is available as a comma-separated value file. It's more than 20 gigabytes stored in a single CSV file. 4 columns of type string and more than 160 million rows. This is the file is taken from this is the basically Reddit place official Canvas history from 2022. To benchmark the remaining 2 formats, I converted CSV file to Parquet and Arrow IPC, and I ran all benchmarks on the same machine. All right, so let's start from CSV. So that's the basically plain text format that uses commas to separate values. It can store numbers and strings in plain text. There is no completion. So any text editor can be used to open this file and edit. It is a very popular data exchange format, even though it has its flaws, but it's still very popular. So here we have 2 tables, one for import, one for export. So let me start from explaining the columns. Reading column, this is basically timings in seconds. For reading a file content, the whole file content into memory as a arrow table. 12.3 seconds for our Wolfram Language prototype, and 5.9 seconds for Python 3.11 and PyArrow version 13.0. And we also use version 13 of Arrow in our prototype. So about 2 times slower. We are investigating why it is. We're hoping to get this similar timings here. Now the conversion column means something different depending whether this is Wolfram Language or Python. So for Wolfram Language, we are trying to design the tabular object to be as close to arrow table as possible. That's why the conversion between these 2 data structures is taking just 17 seconds. What's going on for Python is we are converting from arrow table to the data frame, and that is taking significantly more time than in our scenario. So in total, it's much better for Wolfram Language than for PyArrow. And similarly for export, so conversion for export, again, we're converting from tabular to arrow table, and for Python, we're converting from pandas data frame to arrow table. So that's the conversion. Once they are converted to arrow table, we writing to file. This is writing to the CSV file. And the timing is exactly the same for Wolfram Language and Python. But again, the conversion is much faster here than for Python. And the total time is again about twice as fast here for Wolfram. So that's more or less everything for comma-separated values. Let me move on to the other format. So Parquet format was it's another columnar storage format. It was created and designed for the Apache Hadoop ecosystem, and it's supposed to be very efficient for data storage and retrieval. It supports various compression schemes and encodings. And again, the benchmarks were methodology was exactly the same as before. So reading column shows the timings for getting the data into arrow table in memory, and then the conversion to tabular and conversion to pandas data frame. And the total import time, similar for export. Notice that for CSV, our prototype was about twice as slow as Wolfram. Maybe I will go back to remind you. It was 12 seconds versus 5.9 for CSV import, but for Parquet is, well, more or less the same, slightly faster in my benchmarks. So we are already basically the same speed of reading as PyArrow. Conversion is exactly the same thing. I basically copied the values from the previous table because these are exactly the same data to be converted to data frame or to tabular, and then the total import time 41 versus 192. For exports, again, the conversion timings are the same, and writing is actually much better. 37 seconds versus 81 for Python. And overall, 60 seconds versus 153. Now, I'm gonna talk a little bit about Arrow columnar format. So Arrow library comes with its own format, both for flat and hierarchical data. It's not just format, it's also a protocol for serialization and interprocess communication. And that's why the actual file formats are called Arrow IPC. And what's important for this format, it supports zero copy reads for fast access without serialization, and you will see that on the next slide what I mean by that. It comes with two types, one designed for streaming, which we call Arrow IPC streaming format, and then for random access is the Arrow IPC file format. But I mean, in a sense, they are both files on your file system, but the storage is optimized either for streaming or for random access. So let's start from the stream version of the Arrow IPC. In this case, both in the import benchmarks, both for Wolfram Language and for Python, we are using memory mapping. So the file is loaded into memory and then decoded from memory. Notice the difference for reading, not even 2 seconds to load and to read more than 20 gigabytes of data from a file into memory. It's a little slower for Python, 7 seconds. Again, for both cases, we use memory mapping. So it's hard to explain why Python is few times slower here. Conversions are again the same as for the previous benchmarks, but the total import time is quite impressive for Wolfram language compared to Python. And similarly, the export benchmarks, basically writing times are exactly the same for both scenarios here. So once again, the what I mentioned on the previous slide, this zero copy reads without serialization. That's how you can get 1.9 seconds for 20 gigabytes of data. Only this format supports such feature. And very similar timings for the random access type of ROIPC, 1.8 versus 7.2, and 21 for writing, exactly the same for Wolfram language and Python. So this is more or less everything that I want to show when it comes to benchmarks, and this is the last slide of this presentation. So let me summarize. The new columnar data structure that we call tabular is coming and will probably be released in Wolfram language 14.1. Import and export will support new columnar file formats, at least the three of them that I discussed today. Hopefully there will be more, already mentioned ORC. And benchmark results, these preliminary benchmarks shows that the much better performance for Wolfram language compared to Python libraries. I want to invite everyone to the related talk. Sean will talk on Friday. We'll give some updates to import-export features that are coming in version 14.0, as well as discuss some future directions. All right, thank you for listening, and we may have some time for questions.
Got a couple questions here in the chat. Does Arrow format support random access? If you go back a few slides, he mentioned that Arrow IPC has two different formats. They're both, files on your system, but IPC's streaming files are going to be very efficient if you're reading through the file linearly. But yes, Arrow does have a random access file format that is similar to HDF5 in the sense that it's efficient for accessing random data. We got another question here about improving the DXF, import-export functionality. There is not an existing project to that, but I'm going to go ahead and write down your note. Thank you. Looks like we have another one asking, what format is fastest for large load and save? Example, WDX. Well, that is highly dependent on exactly what your data is. So if you want to serialize a large data set, like a Wolfram language data set, again, there's kind of a touch of vagueness to the question, because is the question serializing the data set itself? If so, Wolfram language has binary serialize, right? So we can serialize a Wolfram language expression in the most efficient format possible. Now, if you actually want to save it in a file format that is more structured and not specifically serialized to a Wolfram language expression, you're probably better off taking the data behind the data set and storing it to one of these Arrow formats. Or something like HDF5 currently.
Yes, I was gonna say that. If you can already try something like HDF5 is quite efficiently implemented in the Wolfram language. And you can, this is the hierarchical data format. So if your data fit that kind of structure, then that should be your format of choice. If not, binary serialize. If for some reason binary serialize is not the
well,
best
binary
option.
serialize if you have a Wolfram language expression that you want to serialize, which would be a data set is a Wolfram language expression. Streaming data and processing it on the fly. So this current iteration, due to the performance of these kinds of things, we're mostly looking at importing large files using these Arrow libraries, but they also have random access type features. And then there is this Arrow IPC streaming format that has this kind of streaming interface. This first stage of development is mostly taking large files and accessing chunks of them. And then we can imagine a future where we start to look at huge chunks of data and how we might process it as a stream. That's a great question.
Right. I just want to add that by default, import will import all the columns, but from the columnar data file. But there is a way to specify which columns you are interested in. And for some reason, you are interested only in the first two columns. It's going to be possible. There should also be possible to actually import specific rows, or maybe not as efficient as columns, but we are trying to work on the partial access also for rows. Okay, I think that's the end of time for questions in these presentations. Thank you for listening and watching.